All right, here we go. Next lesson for chapter 1, 1.3, we have, and please label that in your notes, 1.3. We have graphical and numeric measures of spread. So these are some of the things we're going to look at. Calculate quartiles, interquartile range, and a 5-number summary. We're going to learn about what a box plot is and how appropriate that box plot is for certain data sets. We're going to talk about variability, or the concept of the spread of data, and then understand deviations. So we're going to go through all that vocabulary. This is going to go relatively quickly because there's a lot of information. So just kind of try to keep up. So consider this data. We want to find the mean, median, and mode for the data with and without Michael Jordan's total score. So we have all these basketball players, right? We have Michael Jordan, obviously, with so many more points than any of the other basketball players. One of the greatest, or some people would say the greatest basketball player and even athlete of all time. So I want you to pause the video, find the mean, so add them all together, and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Find the median, or the middle value, and then find the mode, right? With and without Michael Jordan's total score. So mean, median, and mode with and without his total score. Which measure is most affected by his total score? Okay, so again, pause and find those things with and without Michael Jordan's score. All right, so let's look at what this looks like. Hopefully you've got your own values. With Jordan's score, we have a mean of 675 points, the median of 416, and there is no mode. Nothing occurs more than once. Without his score, mean of 507, median of 396, and again, no mode. Nothing occurs more than once. Okay, which measure is most affected by his score? Well, we can see that the mean really varied. It was 675. And then without his score is 507. So if we think about that for a second, why did that happen? Because Michael Jordan scored so many more points than everybody else, his score was an outlier. And that outlier drove that mean way up with his score. We have a much greater mean because his score was so much higher than everybody else's. All right, so again, Michael Jordan, regarded as one of the all-time greatest athletes. You can go ahead and read the statistics. I'm not going to read all of those. But let's go down to this. This is what we want to focus on. A 5-number summary could give a good picture of this data, and we're going to talk about what that is. It uses 5 things. It uses a first quartile, which is the median of the first half of the data. It uses a third quartile, which is the median of the second half. We'll talk about these things again. It also uses a minimum, you know what that is. It uses a maximum, and it uses the median of all the data. So these things are not going to be familiar to you. Your first quartile, or the middle of the first half of the data, and your third quartile, or the middle of the second half of your data. So let's take a look at what that looks like. So if we want to find the 5-number summary of this same data, we're going to start by ordering that data, right? This is already in order, so that's really helpful. And we're going to find minimum. So here's your minimum. Oh, sorry, that's your maximum. We have our minimum down here at the bottom. We have our median. So what's the middle of the data? Well, we have 11 total data points, right? So 1, 2, 3, 4, 5. This is going to be our median, is our 6th value. 6, 7, 8, 9, 10, and 11, right? So minimum, maximum, median. But we also want to find the middle of this first half right here. Okay, so what's the middle of the first half of the data? And then also, what's the middle of the second half of the data? So not including the median. What do we have as the middle of the first half and the middle of the second half? Well, it looks like this is the middle of the first half. So we're going to call that Q1. Whoops. Let's try that again. We want the first half, the middle of the first half of the data, the middle of the second half of the data. So we have our data at the bottom, right here. right? Okay, so the middle of that, it looks like there are 1, 2, 3, 4, 5 values. So we're going to have the middle be that value right there. We're going to call it Q1 or quartile 1. And up here, in the top half of our data, we're going to take the middle of that, and we're going to call that Q3. So our 5-number summary is going to be minimum of 167, Q1 of 288, median of 416, Q3 of 841, and a max of 2,357. Okay, so you can look at it this way as well. So if you order your data from least to greatest, minimum, middle of the first half is quartile 1, median, middle of the third half is quartile 3, and maximum. There's our 5-number summary. Okay, so we would just say our 5-number summary are these values right here. Now I also want to show you how to do that in your calculator. So follow along on your calculator. I'm going to go to stat, okay, or statistics. So when I go to my stat menu, I'm going to go to edit, and I have my lists. Now I've already entered all the data into my list, but you would enter those scores into your list, right? So I entered them all in, starting at 2,357, entered those scores into my list, list 1, and from there, I'm going to go back to statistics or stat, and this time I'm going to go to calc or calculate. So, all right, so I go back to stat, I go to calculate, and I'm going to go to option 1 variable statistics. All right, so when I go to that option 1 variable statistics, I want list 1, so L1, that's where I entered my data. So I'm going to go down to calculate. All right, and there's a bunch of numbers here. I'm going to show you the ones to focus on. So we want our 5-number summary, right? All right, well, I'm going to start at, let's see. If I look over to here, I have N, right? That's the number of values in the set. So I have 11 values in the set, right? Here's my minimum. So there's the first value of my 5-number summary. Q1, second value. Get rid of that. You can actually see them all right here. All right, so there is my 5-number summary in my calculator. So I can do all of those in my calculator without having to list everything in the, oops, let's try that again, without having to list everything from least to greatest. Okay, oops. All right. One other thing to notice here on your 1 variable statistics is your mean. You'll also see your mean up here, X bar. X bar is also your mean, so you can find your mean in your 1 variable statistics as well. Let's get rid of that for a second and move on. It's going to be a relatively long video just because of the number of concepts we're going over here. 5-number summary helps you understand the spread of the data along the number line. It shows you how that data is spread out from the minimum to the maximum, which other things don't do. We don't have, a bar graph doesn't do that, right? So this is a box plot. The box plot shows that 5-number summary and again shows how the data is spread out. It's a visual way to show that 5-number summary. Sometimes we call it a box and whisker plot, and you can kind of see why. You have this box in the middle, right? And then you have these kind of whiskers coming out on each side. So we can also call it a box and whisker plot. So this is how we use, or this is how we draw a box and whisker plot anyway. So you can see I have this from the previous page. I'm just taking that 5-number summary and I'm putting them on my number line essentially. So I have my minimum right here, right? Q1 is right here. My median is right here. Q3 right here. And my maximum is all the way over here. So I'm going to plot those points, all 5 of those points, along my number line, sort of like a dot plot. But then I'm going to draw this box, right? So I'm going to draw a whisker going from my minimum to Q1. And then I'm going to draw a box around Q1 and Q3 with a line going through the middle to show my median. And then I'm going to draw another whisker going all the way out to the maximum. Right? So there's my box and whisker plot. That's what it's going to look like. It's a good way to compare two data sets. If I take a look at these two data sets on the side, I can see a box and whisker plot vertically as well. You can look at which class has the greater range of scores. So if you look at minimum to maximum, you can see that Class A has a range of 30 all the way up to 95, and Class B only has a range of about 65 to 95. So you can see that Class A has a greater range. Which has a greater IQR? Well, let me explain what IQR is. IQR is interquartile range. So you can kind of tell from that term that the interquartile range is just going to be the range of the box. Okay, it's going to be the range of Q1 to Q3. So what is my range of Q1 to Q3? Well, if I do the best I can with my range here, it looks like this is going to be at about maybe 63. And it looks like Q3 maybe is at somewhere around, let's see, it looks like maybe 85. I'm probably a little off with those values. So I have an interquartile range of 63 to 85. So if I subtract those to find my range, I'm going to find an interquartile range for Class A of about 22. Right, now if I look at Class B, let's say this is Q1 is somewhere around 70. Q2 is somewhere around 90, right? So that interquartile range is only 20. So the interquartile range for Class A is slightly greater. And I can tell that because the box is just slightly larger. In which class did the greater fraction of students score above 80? Well, again, let's take a look at our two box plots. So the fraction of students that scored above 80, so if I look at that 80 mark, which is right here, right? So it looks like the greater fraction of students that scored above 80 is going to be right here or in Class B. One other thing about a box plot, though, is it's not useful for seeing individual data. I don't see all the separate points on this box plot. So if I wanted to say, well, how many students got exactly a grade of 70 from Class A? I can't tell exactly how many students got a grade of 70. So you can't see individual data on a box plot. All right, just a couple more things. We have a deviation. A deviation is a measure of how far from the center something is. Okay, how far from the center is a particular data point. So for example, if you're in Class B, above where the mean test score was 80, and you have a score of 86, your deviation is 6. So if the mean, actually I'm going to write that as x bar. I want you to get used to that. If the mean, or x bar, is, let's see, we said 80, but your score is 86, then your deviation is going to be 86 minus 80, or 6. You have a deviation of 6. You're 6 points away from that mean score. Now that's a positive because you are above the mean score, so it's a positive 6. A test score of 78 has a deviation of negative 2 because we have, again, a mean score of 80. So we're going to do 78, your score, minus 80, the mean score, and that's going to give us a negative 2 because you're below the mean score, so your deviation is a negative 2. So deviations can have a sign, a positive, a negative, or negative, depending on if you're above the mean score or below the mean score. All right. There's also something called, well, actually, let's look at this. I'm going to get rid of this. Yeah. All right. So if I take a look at these scores right here, right? The mean is 80. Again, like we said, our mean score is 80. Add them all up, divide by 8, and you get a mean score of 80. Here are all of our deviations for all of our individual scores. So if you scored a 65, your deviation is negative 15, right? Or 65 minus 80. 70 minus 80, negative 10, and so on. So if I do every single deviation, 72 minus 80, 75 minus 80, 85 minus 80, 87 minus 80, 91 minus 80, and 95 minus 80, I'm going to see that the sum of all of those deviations is 0. Okay, so when you do your deviations, you're going to find that that sum is 0. All right. So like I said, a couple more things. The absolute deviation is the positive value of the deviation. The distance from the mean, remember, is the deviation. The absolute deviation just takes the positive value of all of that. So remember, if you scored a 78, your deviation was negative 2. Well, your absolute deviation is just going to be 2. Okay, so absolute deviation is just the positive value of all the deviations. Okay? So again, positive value of the deviations is the absolute deviation. One other way to measure spread that uses all of the values is to give the mean absolute deviation. You know all these words already. Remember, mean is like an average, right? Adding together and dividing by what you have, and dividing by how many values you have. And you know, because of what we just said, right, that absolute, so there's the average, the absolute deviation is just the positive deviation score, okay? So my MAD, or mean absolute deviation, is going to be all of my absolute deviations, or all of the positive deviations. So even if the deviation was a negative 2, we're going to, for our absolute deviation, turn that into a positive 2. I'm going to add all those deviations together and divide by 8 and take the mean of them. So add up all the deviations for each and every score, divide by how many scores you have. So I end up with 76 divided by 8, and I get a mean absolute deviation of 9.5. Okay, so one more time, take all of the separate deviations, make them positive, add them all together, and divide by 8. That's the number of values that you have. And I get a mean absolute deviation of 9.5. Okay, so that shows me about how much each score is spread out from the mean. So in this case, our mean was 80, right? We found a mean of 80. And our mean absolute deviation of 9.5 gives us a picture of about how much each individual score is spread out from that 80. So the scores in general are about 9.5 points away from the mean score of 80. Okay, so again, the value that we just found tells us the average value is 9.5 points from the mean. Some are more than that, some are less than that. If you were given another sample with a much larger mean absolute deviation, what would you be able to tell about that sample? So let's say with that same set of data, with a mean of 80 and a mean absolute deviation, in other words, the scores were about 9.5 points from the mean. What if our mean absolute deviation in this case was 20? So what would that tell us about the data if our mean absolute deviation was much larger? Okay, I could maybe say they're much more spread out from that mean if I have a larger mean absolute deviation. So that can tell us some other things as well, right? Let's see, one other thing to notice about this is just, again, the sum of the deviations, or a measure of how far from the mean an observation is always going to be 0. So remember that. And our mean absolute deviation tells us about how far the values are from that mean. Some are going to be further away, some are not going to be as far away. Okay. I'm not going to spend much time on this one. We're going to talk a little bit more about this in class. So you learned 3 measures of spread. Range, the difference between the maximum and the minimum, right? Just to review. Interquartile range, or the difference between Q3 and Q1. And the mean absolute deviation, or all those deviations added together, all the positive deviations added together, divided by how many scores you have, how many data points you have. Statisticians are going to tell us that we've missed two important measures of spread, though. Variance and standard deviation. Variance and standard deviation. So just really quickly, and then again, like I said, we'll talk a little bit more about this in class. The sum of the squares of the deviation divided by one less than the number of values is called a variance. Okay, so if you square all of the deviations, so if a deviation is 2, when I square that, I get 4, right? So if I square all of the deviations and I divide them by, I add them together and I divide them by one less than the number of values, this time I'm going to divide by 7 rather than 8. That's called variance. Okay. And then I also have the square root of the variance is going to be called the standard deviation. Right? So if I get that value for my variance and I take the square root of those, I'm going to have the standard deviation. Again, we'll learn a little bit more about that in class. Make sure, however, you have these things, right? Your range, interquartile range, and let's see, 3, what do we have? We have range, we have interquartile range, and I missed mean absolute deviation and mean absolute deviation. So make sure you have those 3 things for sure in your notes, okay? Let's just do one of these then together. Give my 5-number summary and create a box plot. So I'm going to go to my calculator and I'm going to enter these in. All right, so remember, you go to stat. So I went to stat and edit. And I went ahead and edited a list. So I'm putting all my values in list 1. And from there, I'm going to go back to stat. This time I'm going to calculate. And I want to calculate my option 1 variable statistics. Okay, go ahead and calculate. You're in list 1, which is what you want. And enter. And I'm going to scroll down and I'm going to start at my minimum so I can see all my 5-number summary. So my 5-number summary is right here. I have 1 for my minimum, 2 for first quartile, 5 for my median, 7 for third quartile, and my max of 10. And again, if you scroll back up, you can see your mean, which is X bar, right? But we don't need that for our box and whisker plot, or box plot. So I'm going to go ahead and do my number line down here. I have a minimum, so I'm going to start at 0. So my max is 10, so I'm going to go up to 10. Right? Okay, so I have a minimum of 1. Here's going to be 5. I want to make sure to do this relatively accurately. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do the best I can without a straight edge. I have a minimum of 1. So I'm going to go ahead and plot my minimum. I have a Q1 of 2. So I'm just going to go ahead and make a little dot at my Q1. The median of 5. So again, I'm going to make a dot at median of 5. Q3 of 7. So that's going to go there. And a max of 10. So there's my 10. All right, so I'm going to draw a line from my minimum to Q1. Here's my median. Here's Q3. I'm going to draw my box. And then I'm going to draw my last whisker out to my maximum. So there's my box and whisker plot. Again, this is minimum, Q1, median, Q3, and max right there.